Okay, second part here is about the applications of the operation amplifier. So this circuits here already, you need to remember them. Even if I give you a test, I will give you the equations for this circuit. But when you look at the circuit like this, any one of them, you have two circuits here. There is a known relation between the output and the input. For example, if you look at circuit number 1, the one in the left, this is the output voltage and this is the input voltage. Okay, this circuit is called the inverting amplifier. For the inverting amplifier, this input is connected to the ground, and the second input, which is this one here, is connected to the input through a resistor and connected to the output through another resistor. So here you can call this RF, you can call it R2, you can call it any name you like. This one you can call it R1, you can call it Rn, it doesn't matter. So I really don't care. There's one here, this node is connected to the input through a resistor and connected to the output through another resistor. And the relation is very easy. The output voltage, look at it from right to left. This is the output voltage equal what? Equal negative RF divided by R1 time the input, which is VI, So again, VO, the output, equal what? Equal negative RF divided by R1 time VI, which is this equation here, this equation. Okay, so when you look at this equation, first it has a negative sign. That's why we call it inverting amplifier. And the relation between the output VO and the input depends on the values for RF and R1. For example, if RF is more than R1, RF is 100 and R1 is 1, for example. So the output equal negative 100 times the input. So in this case, this is called amplifier. So this is amplifier. Why? Because the output RF over time, RF is more than R1. For example, again, if RF is, example, this one is 10, R1 equal, for example, 2. Okay, 10 and 2. So RF is 10 and R1 equal 2. Then what is the relation? VO, in this case, VO equal what? Equal negative 10 divided by 2. 10 divided by 2 will be 5. Negative 5 times the input, VI. So it's very clear that the output is 5 times the input. That's why we call it amplifier. And it is negative 5. That's why we call it inverting amplifier. So if the input, for example, is a sine wave, then the output will be opposite of this, negative sign. We'll add a negative sign. So what if, for example, again, what if RF is less than R1? If RF is less than 1, then in this case, the output is less than the input in amplitude. So again, assume, for example, RF equal 10 is 2. RF is 2 and R1 is 10. So this is 10 and RF is 2. So what is the relation between the output and input? So in this case, VO will be negative 2 divided by 10 time what? Time VI. So actually it's 0.2. Negative 0.2 VI. Okay, so you multiply the input by 0.2. So you're decreasing it. You are decreasing it. So in this case, this is called attenuator. So Sorry here for because I am writing with the mouse again. Attenuator. So if RF is less than R1, then you are decreasing the input. You are multiplying the input by a small number, 0.1 number that is less than 1. So in this case, called attenuator. And this is useful in case if you have some noise, for example. If you have a source of noise and you want to decrease it, so how do you do that? You multiply it by 0.2. So you actually divide it by 5. You divide it by 5 because this is V, this equal negative V1 or Vi divided by 5. So actually decrease the amplitude by 5 times. If the amplitude, for example, is 100, then the amplitude of the input is 100, then the amplitude of the output is divided by 5 will be 20. So you decrease it from 100 to 20, which is good. So you decrease the noise. But if it is the opposite, like here, RF equal 10 and R1 equal 2. So this means that you multiply the input by 5. That's why you call it amplifier. So here you have two applications. One is amplifier and one is attenuator. Amplifier and attenuator by the same circuit. You don't have to change anything. All what you have to do is to change or to select the values for RF and R1. Okay. What if RF and R1 are the same? Like this one here. Assume that RF is 1, R1 is 1. Okay, RF and R1 are the same. What will happen? In this case, VO equal negative 1 over 1 time VI. So it will be negative VI. So if RF equal R1, they are the same. Okay, so there is no other amplification here. You do not amplify or attenuate. You just invert. So in this case, we call it inverter. Inverter. So this circuit here is just inverting circuit. Inverter. Yeah. Okay. So if you just need to invert the sign of a signal, you have a signal and you want to change the sign. If it is negative, you want to make it positive. If it is positive, you want to make it negative. All what you have to do is just draw this simple circuit here, and you select the two values to be the same, RF and R1 to be the same. There's the same values. That's it. Same values. There's no difference. There's no difference. So for example, if you look at circuit like this, it is all this. Okay. Assume that you have a circuit like this. Here it is. This is the ground. And this is the input. This is the output. This is VO. And you have a resistor here. And this, for example, is 15 ohm. And this one is 3. Okay. And this one is, for example, 2. Or let's say this just, let's call it just VI. Okay. What is VO? VO will be what? Will be negative 15 divided by 3 times VI, which is negative 5. Negative 5 times VI. So since it is negative 5 VI, it is amplifier because you multiplied by 5 times. Amplifier. Amplifier. And since it is negative, it is inverting amplifier. Inverting. Inverting amplifier. If we do something else, assume that you have a circuit like this. There it is. Same circuit. And this one is, for example, 1. This one is 10. And this is VO. And this is VI. So what is VO? This one will be -1 divided by 10 times Vi. So actually you divide Vi by 10. Okay, so it is -Vi divided by 10. So this one is inverting, but it is attenuator. Why? Because it decreases the output. The output will be the input divided by a number. Okay. What if you have another circuit, for example, like this one here? Same circuit. There's no difference. Okay, it is. Let's delete all this. Okay, and this one is, for example, 10 ohm, and this one is 10 ohm, or 1 ohm and 1 ohm. What is the output here? VO equal what? Equal -10 divided by 10 times VI. So VO equal -VI. -10 will cancel with 10. So this is just -VI. So VO equal -VI. Okay. So if this is the case, then in this case it is just inverter. So the same circuit, okay, you can do 3 jobs. You can do inverting amplifier, you can do inverting attenuator, you can do inverter only, just inverter, if you want to just change the sign. Okay, by selecting RF and R1. If RF is more than R1, this is amplifier. If RF is less than R1, it is attenuator. If RF and R1 are the same, it is just inverter. There is another circuit also here, which is called non-inverting amplifier. And from the name, it is amplifier, but it doesn't change the sign. So if you look at the relation between the input and output, okay, see the output here, VO equal what? VO equal 1 plus RF divided by R1 times the input. So 1 plus RF divided by R1 between brackets time VI. This number is always more than 1. Because you cannot have negative resistance. So RF and R1 is always more than 0. So 1 plus anything that's more than 0 is usually more than 1, of course. So VO equal 1 plus RF over R1 between brackets times VI. So that's why you call it non-inverting, because you don't have any negative sign here. Okay. So this one, if you, for example, if I ask you to design a circuit so that VO equal 3 VI, so you can use this one here. You can use this circuit. Why? Because it is positive here. It's positive. Okay. There's something here. If you want to know what's the difference between these two, if you compare this circuit and this one, what's the difference between them? Okay. Look at the input here. This is the input. You have, in both of them, you have 2 resistors, R1 and RF. There's no difference. So what is the difference? The difference is that you switch the location of the ground and the source. So the source here was connected to here, this point. There it is, the source, and the ground is connected to this one here. So you switch the location. Okay, so this point is connected now to the source, and this point is connected now to the ground. So you see the different. Oh, sorry, this one here, this one, and this one. This one and this one. Here's okay. So these 2 points here. So if you switch this one, the source, you move it here, and the ground, you move it here, then this will make it inverting amplifier. So it's the difference between them that you just, it's very simple change, that you switch the location of the ground and the input voltage. Okay. So now let us see, for example, if you have a circuit, if I said design a circuit, let us erase this. Sorry. This is all this. If I said I want, for example, here, I want V1, VO to be 3 times VI, like I explained before. So if this is the case, then of course you have to select non-inverting amplifier. And for the non-inverting amplifier, the relation is known here. It is 1 plus RF over R1, all between brackets, time VI. And since all of this equals 3, then now this means that RF over R1 equal 2, for sure, equal 2. Okay, so 2 plus 1 is 3. Then all what you have to do is just draw the circuit for the non-inverting amplifier. Here it is. You have a VI here, whatever this one, VI. And you have this one here, R1. And this is R2. And this is VO. And this is RF. Okay, and this is the ground. Okay, and you select the values for RF and R1. R1 equal, for example, 1. RF equal what? Equal 2, for example. RF over R1 equal 2. So 2 over 1 will work. If this is, for example, if you can select this one to be 20, and this one is 10, 20 over 10 is 2. Any two numbers, so that RF over R1 equal 2. So you have unlimited solutions. So this is the non-inverting amplifier. This is a non-inverting amplifier. But remember that this circuit will not work. This circuit will not work if, for example, if I ask you to design a circuit so that I want to design a circuit so that VO equal negative 0.7, for example, positive 0.7 VI. If I ask you to design a circuit so that VO equal positive 0.7 VI. So how do I do that? You cannot use this circuit now. Why? Because this is more than 1. This is more than 1. But here you have 0.7. So what is the solution here? The solution is to use inverting amplifier. Let us see how we do that. So let us erase all this. So here we'll have inverting amplifier. We need VO to be positive 0.7 V1 VI. This is what I need. So in this case, you have no option but to select inverting amplifier. So the inverting amplifier look like this. This is connected to the ground. And this is connected to the input, which is VI. You can make the source, of course, or you can just keep it like this. And there's another one here. So this is RF, and this is R1. Okay, and then you select the two values to give you 0.7. How do you make it 0.7? You know the equation. The equation is VO equal what? Equal negative RF over R1 times VI. Okay, so you want this to be 0.7. You want RF over R1 to be 0.7, then you can select, for example, this one to be 7 and this one is 10. This will work. So this output here equal what? Equal negative 7 over 10 VI. Negative 7 over 10. So it will be negative 0.7 times VI. Negative 0.7 times VI. That's the problem here, that I have negative. This is negative. I don't need negative. I need it to be positive. So if you want to make it positive, it's very easy. All what you have to do is just convert it to, or use inverter. Use inverter. You will change this one from negative to positive. You want to make it positive 0.7 VI. So I want to change it from negative to positive. So you have to select inverter. The inverter circuit look like this. This is the inverter. You can make it anywhere as you like. There it is. The same circuit. There it is. Okay, so this is an inverter. And what are the values? The values, you can select 1 and 1. So this is called inverter. Inverter. So the inverter will change the negative to positive and the positive to negative. Then all what you have to do is just connect this this one here. Connect this one here to the input to this point. Okay. So now what is the input of the inverter? The input of the inverter is negative 0.7 VI. Because I connected it to the input. So if the input is negative 0.7 VI, the output will be positive 0.7. So the output here will be positive 0.7. Okay, so this will be the circuit now. This will be the circuit. You can draw it in a better way, of course. If you want to draw it in a better way, you can just try to adjust it a little bit. So let me erase this one here. Okay, delete this one here. So we'll draw the first circuit. You have two circuits. So this is the first one. It's connected to the ground. You have a resistor here. And this is the output. So this is VI. And this is 7. And this is 10. Okay, so this will be the output here, whatever. And then you draw the other one. The other one will be same like this one here. So this is connected to this one here, but you have a resistor. And here you have a ground. This is 1 and this is 1. So this will be the last output here. So now let us follow it from left to right. The input here is VI. Okay, this resistor here is 7 and 10. Then the output at this point here is what? Is negative 7 over 10 times VI. So this is the output at this point here, which is negative 0.7 VI. Okay, so this will be the same input here of the operation of the inverter. Then the output will be positive of this number. So it will be 7 over 10. time VI. Time VI. So this is the output at this point. So this circuit here is a circuit to design the output equal 0.7 time VI. I hope you understand it now. Now let's return back to the slides. So this is the first two applications. One is inverting amplifier, which has three applications. One is inverting amplifier, one is attenuator, one is just inverter. The other one is non-inverting amplifier, which is amplifier, but if you have the amplification is more than one, cannot be, for example, 0.7 like what we have here.